Good morning, everyone. I am Caleb Emmanuel O. Frias from STEM12A, and today we're going to solve some physics problems from Chapter 22, Gauss Law, problems number 22.13, 22.15, and 22.31. First problem. Two very long uniform lines of charge are parallel and are separated by 0.22 meters. Each line of charge has a charge per unit length 5 times 10 raised to negative 6 coulombs per meter. What magnitude of force does one line of charge exert on a 4.9 times 10 raised to negative 2 meters section of the other line of charge? First of all, we're going to find the magnitude of force exerted on a 4.9 times 10 raised to negative 2 meter section of the other line of charge. So we're going to use the first equation, which is equal to the electric field times the charge. So in order to get the charge, we're going to derive from the charge density formula, which is lambda equals to charge over the length. So it will be equal to the Q equals to length lambda. So after that, we're going to substitute it in the first formula, which will become to F equals to 1 over 2 pi epsilon times lambda squared L over R. So after that, we're gonna substitute the given values to the formula, and then after that, we're gonna get 0.1 newtons. Next problem. How many excess electrons must be added to an isolated spherical conductor 40 centimeters in diameter to produce an electric field of magnitude 1170 newtons per coulomb just outside the sphere? So first of all, we're tasked to find the number of excess electrons. And in order to do that, we're gonna use the electric field formula, which is E equals to K times Q over R squared. And then we're gonna just use algebra to focus on finding the charge, which is Q, which will become Q equals to E times R squared over K. So we're just gonna substitute the given values in the formula, which will become to 1170 times 0.2 squared over 9 times 10 raised to 9, which will become 5.2 times 10 raised to negative 9. So after you get the charge, you just divide it by uh, the charge of one electron, which is 1.6 times 10 raised to negative 19. And after you do that, you're gonna get 3.25 times 10 raised to 10 electrons. So the last problem, at time t equals 0, a proton is a distance of 0.36 meters from a very large insulating sheet of charge and is moving parallel to the sheet with the speed of 9.7 times 10 meters per second. The sheet has a uniform surface charge density 2.34 times 10 centimeters squared. So what is the speed of the proton at t equals to 5 times 10 raised to negative 8 seconds? So we were tasked to find the speed of the proton at t equals to 5 times 10 raised to negative 8 seconds. And in order to get the magnitude of the speed, we're going to use the Pythagorean theorem. And then we're going to use the force formula, which is equal to the force equals to mass times acceleration. And then the mass is the mass of the proton, which is 1.67 times 10 raised to negative 27. And for the first, we're gonna get it from from multiplying the electric field by the charge of the proton, where E, the electric field, is equals to sigma over 2 epsilon naught. So you just substitute the given value in the formula in finding the electric field, and then you will get 132 newtons per coulomb. And then after that, you're just gonna multiply the what you got from the electric field to the charge of the proton, which will then be equal to 2.11 times 10 raised to negative 17 newtons. After that, you're going to use the force formula and then use algebra to focus the formula into finding acceleration. So it will become A is equals to force over mass. And after that, it will equal to 1.16 times 10 raised to 10 meters per second squared. So you're going to use kinematics in order to get the final velocity at the y component, and then you will get Vy is equals to V naught plus acceleration times time. And after substituting the values to the formula, you're gonna get 632 meters per second. After that, you just substitute the values from the x and y components in the Pythagorean theorem, which will then be equal to 1.16 times 10 raised to 3 meters per second. Thank you for watching and God bless you.